Hello, everybody. Hope you're doing well. So today's lesson is going to be chapter 1.2. So the first chapter was kind of just an intro to things. This is kind of like the next extended, like, hey, what's going to happen? So 1.2, we're going to talk about evaluating algebraic expressions. Given values for the variables, we're going to translate word phrases to algebraic expressions. We're going to talk about solutions of equations. We're going to talk about solutions from a set. So a set is just like more than one possibility. And then we're also going to talk about the difference between expressions and equations. What does that look like? All that fun stuff. So this chapter does have a good amount of vocabulary. So the first thing we're going to talk about is what a constant is. So a constant is a fixed, unchanging number. So that could be like a 3, that could be a 5, that could be a 7. It's just some kind of number. Whereas a variable, and this is where a lot of people get freaked out. It's kind of interesting when I talk to adults now. They're like, man, when we started bringing in letters to math, that's when things kind of got crazy. So a variable is just a symbol. So it's representing some kind of number, but we don't know what that number is. And so most of the time people use X. You can also use Y. You can use Z. You can use any letter in the alphabet. But for some reason we just chose X. And if you look at your calculator, X, Y, and Z is kind of like the main ones there. And then finally an expression is just a combination of these things. So we're going to have some constants, some variables. We're going to talk about other things like coefficients, which we're going to talk about as well. And remember, something we're talking about at the end too is the difference between an expression and an equation. So the difference is when I think about the word equation, I think about the equal sign. And so equations have equal sign in them, expressions don't. So some examples of expressions are things like x plus 5. So we have the variable x and the constant 5. No equal sign, that comma is just there to kind of separate them. Same thing with 2m minus 9, and then even that 8ap squared plus 6 times the quantity of p minus 2, like that thing is still an expression because it has constants, it has coefficients, and it has variables. So that's just kind of some terminology that I'm going to try to use moving forward. And just kind of, how that works. So if you're new to the series, how this works is that I'm going to do the first example. You'll see there it says teacher example 1. I'm going to go through those, and then I'm going to have you pause the video, and then there's some classroom examples here. So this says evaluate the expression for n equals 2. So I have this 10n plus 5. So the first step that I always do, and I've done this forever, and I'll explain as we kind of go further along why I do this, is anywhere I see a variable, I just put a set of parentheses. So even down here, I'm going to put a set of parentheses in that. And so now we're trying to evaluate this for n equals 2, so I'm going to put a 2 in there. So the first question I have to ask, and something that we maybe have talked about, is this idea of PEMDAS. Remember, I like to write PEMDAS like this. So I now have to go through, and the first question is, what is going on between this 10 and this 2? Well, if you look at it closely, you'll realize that 10 is being multiplied by 2, so actually I'm going to do that one first. So 10 times 2 is 20, and then plus 5, and so that's going to be 25. Similarly down here, I'm going to put a 2 in there, and I start again. Do I have any parentheses? Well, I do, and I actually have an exponent first, so I'm going to do that first. So I have 3 times 2 squared. Remember, this is actually being multiplied here. So 2 squared is going to be 4, so 3 times 4 is going to be 12. So the reason why I do the parentheses is because if I don't do the parentheses, let's say down here, I'll have this thing, and a lot of times you might see this first and think that that's supposed to be 3 times 2, and then you get that squared, and that's going to be 36, which is the incorrect answer. So anytime, it's just a little trick that I do, and it seems to work. Once we get into negative numbers, you'll see exactly why that works. But I would just encourage you, anytime you have a spot where you're evaluating for some expression, that you put some set of parentheses in there. So go ahead and take a second, pause the video, and try these ones, and then you can unpause it, and I'll go through it. Okay, so here we're evaluating for p equals 3. Here again, I'm going to rewrite this as 16 parentheses minus 8. In the parentheses, I'm going to put a 3. I'm going to do this step first because we're doing multiplication before addition or subtraction, right? 16 times 3, I believe, is 48. Minus 8 should give us a 40 for that one. Okay. Similarly, down here, 2 times p cubed. Now, again, put it in parentheses. 3 cubed, 3 times 3 is 9 times 3 is 27. So I think this is 2 times 27, or I believe that is 54. So if you guys put them in parentheses, like I said, you'll have a much better chance of being able to see. I'm sorry, I forgot it does it for you, but anyways, you'll have a much better chance of realizing what you do first and when you do it, if that makes sense. Okay, so now another reason why I do this is, let's say that we have multiple variables, right? So in this case, we have x equals 3 and y equals 4. So again, I always rewrite this anytime I see a variable. But now, instead of like just plugging in one number, because that's what we're talking about here, x in this case is going to be a 3, so I see this is 2 times x, so that's 2 times 3. But then this time y is 4, so 4 times 4 goes in there. So 2 times 3 is 6. 4 times 4 is 16, and I believe that 6 plus 16 should give us 22. Similarly, I know it's like, and you guys will find out, I know that I take a long time sometimes to do stuff, but trust me, I've learned that I do math 6 days a week. I still can do it this way. It just makes a lot more sense for me, and it kind of, like, the biggest thing I learned about math is that, limiting the number of errors you can make is huge. So in this case, by putting parentheses, taking my time, plugging in the numbers where I need to plug in, it's going to limit my opportunity to make errors, which is the key here. 2 times 3 is 6. 5 times 4 is 20. And 3 times 10, I believe, is 13. Be careful on this one, because when you do this, hopefully you can see that these can be simplified to just 2 over 1. Another way of writing that is just 2. Okay, so again, take your time. Rewrite it, put in the numbers, excuse me, where you need to. All right, go ahead and pause the video and try these ones by yourself. Okay, so again here, I do it this way. The computer does it a little bit differently, but I'm just gonna at least set it up so you guys see what I do. They kind of did that here. It's nice because they actually used it in different colors, so you can do that too if you like to write in different colors. That's something you can do. So again, 4 times 6, I believe, is 24. 5 times 9 is 45. Add those two together and you get 69 there. Similarly, with the same one on the right, instead of putting parentheses, they just use different colors. So they use X's are blues and Y's are red. Same thing. Simplify the top, you get 24 minus 18, which I believe is 6. So that one you end up with a fraction. It's okay. It's okay to end up with a fraction. That's totally fine. So hopefully those made sense. Yeah, so moving on to the next thing we're going to talk about is we're going to talk about writing algebraic expressions, and this is the key right here. These words that are kind of highlighted here are really the key. I like that they actually used them in different terminology, but you have to think back to like elementary school and like what do these terms mean. So remember, a sum in this case means we're going to be adding, where a difference is going to be subtracting. A product is going to be multiplication, and this one says multiplication and this one says plus. The only one we don't have is what's called the quotient, and that's going to be division. So again, take a second, think through that. I think you guys can do it. So sum is adding, difference is subtraction, product is multiplying, and quotient is division. Okay? So when we're talking about the sum of 4 and a number, well, we don't know what that number is, so we get to pick a variable. Just to keep it simple, I'm going to pick x. Can you pick any letter in the alphabet? Sure. I'm just going to put that there. So a sum of 4 and a number, I would write that as 4 plus x. Can you write it as x plus 4? For sure. We'll talk about that in a later video. The difference of 10 and a number. Now this one does matter which way you write it. So I would say that the difference of 10 and a number is going to be x minus 10. 10 minus x and x minus 10 are two different things. I would encourage you to write that as x minus 10. The product of 3 and a number. So again, a number is going to be x, so here is just going to be 3x. Now this is interesting. 2 multiplied by the sum. 2 multiplied by the sum of a number and 7 is going to be that. Can you also write it as 2, 7 plus x? For sure. Can you write this one as x times 3? For sure. The only one that doesn't work here is difference. And you can think about it, like think about a number. Let's pick 20 for x. Is 20 minus 10 the same as 10 minus 20? No. What's 20 minus 10? 10. What's 10 minus 20? Negative 10, so those are not equal. So difference and quotients are actually going to have the same rules. Hopefully that makes sense. So remember, the biggest key with this one is sum is adding, difference is subtraction, product is multiplication, and quotient is division. Go ahead and take a minute, pause the video, and try these ones. Okay, remember, difference is subtraction, so this one's going to be 48 minus x. Product is multiplication, so that's 6x. And then this one's the hardest one. 9 multiplied by the sum of a number and 5 should look like that. Okay, so hopefully that made sense. Again, I don't want to keep saying this. Sum is adding, difference is subtraction, product is multiplication, quotient is division. Okay, next topic. Deciding whether a number is a solution to the equation. So we have this equation now, and it's equation because we have the equal sign here. And we're trying to figure out, does this work? How do you do that? Well, what do I stick in for P? The 2. I know that's written kind of weirdly, so hopefully that makes a little bit of sense. 8 times 2, I believe, is 16 minus 10. So the question is, does 6 equal 5? No. So is 2 a solution for this equation? No, it's not. So that's all we're talking about there. I know that's written kind of weirdly, but I just wanted to show you one of those just so you can kind of see what they're talking about in your homework. But yeah, so just a heads up. So go ahead and try this one. Pause the video and take a second. So this one, I'm going to do it down here, 0.1. Remember, this you're going to do your parentheses first. So I have 0.1 times 8. Does that equal 0.8? It sure does. So yes, 5 is a solution. So hopefully that makes sense. Really quickly, the last thing we're talking about, and I kind of hinted at this at the beginning of the video, just to kind of wrap it up again, equations versus expressions. Equations have equal signs, expressions don't. That's pretty much the biggest thing. The nice thing about equations is once we solve equations, we can plug the answers back in to see if they work. Expressions, you can't really do that. So in this case, looking at this first one right here, what plus 4 equals 11? Well, if I think about it, it's going to be 7. So I get the fact that x is equal to 7, and I can literally plug that back in here, and I can tell myself that 7 plus 4 equals 11, and it works out. The expressions, you can't really do that with. So I'm kind of a bigger fan of equations. We're going to talk a little bit more about equations than equalities, but anyways, side note, but I think you kind of get the gist. So the last lesson for today is A an equation, is B expression. Pause the video, see what you think, and then I'll come back and review it. That was awkward. Sorry about that. So 1, yes, that is that's an expression because there's no equality sign, there's no equal sign, so that's an expression. And the second one is an equation because there is an equal sign. So yeah, so that's it. So that's lesson 1.2. If you guys have any questions, let me know.